Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions, the mystery of the Fermi paradox. If intelligent life is common, where is everybody? Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction, not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. In 1950, over lunch at Los Alamos National Laboratory, the physicist Enrico Fermi asked a simple question. The Milky Way galaxy is 13.6 billion years old. It contains at least 200 billion stars. Most stars have planets. A significant fraction of those planets are in habitable zones. Life on Earth appeared within the first billion years after the planet formed. Evolution produced intelligence. Intelligence produced technology. Given billions of years and hundreds of billions of chances, the galaxy should be teeming with civilizations, some of them millions of years older than ours, capable of engineering on scales we cannot imagine. So where are they? The silence is total. In 60 years of organized searching, we have detected no alien signals, found no megastructures in the infrared surveys of the galaxy, seen no evidence of engineering on any scale anywhere in the cosmos. Either intelligent life is extraordinarily rare, possibly unique to Earth, or civilizations that reach our stage tend not to survive it. Both possibilities are deeply unsettling in different ways. The Fermi paradox is not a curiosity. It is arguably the most important unanswered question in science. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Space exploration has produced many surprises, but perhaps none as persistent as the anomalies that professional scientists describe and then struggle to explain. These are not the claims of amateur enthusiasts or fringe theorists. They are the published findings of researchers at NASA, the European Space Agency, and major research universities, documented in peer-reviewed journals and presented at professional conferences, then quietly filed under requires further investigation while the scientific mainstream moves on to the next mission. The anomalies take different forms. Unexpected geological features on planet, RE surfaces that do not match known formation processes, electromagnetic signals that arrive from directions where no known source exists, orbital mechanics of small bodies that deviate from the predictions of established gravitational models in ways that suggest an additional, undetected force. Each individual anomaly might be dismissed as an instrument artifact or a modeling error. But when anomalies accumulate across multiple missions, multiple instruments, and multiple research teams, the collective weight becomes harder to discount. Science advances precisely by taking anomalies seriously, by treating the things that do not fit the model as invitations to improve the model rather than as embarrassments to be minimized. The history of physics is largely a history of anomalies. The precession of Mercury that Newtonian gravity could not explain, the cosmic expansion that Einstein refused to accept, the dark matter that bends light with no visible source. Each one, properly investigated, expanded the boundaries of what we understand. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter. the core evidence surrounding the Fermi paradox. If intelligent life is common, where is everybody, is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. The Milky Way galaxy is approximately 13.6 billion years old and contains between 200 and 400 billion stars. Our own solar system formed 4.5 billion years ago, roughly two-thirds of the way through the galaxy's history. This means that if Earth-like planets with similar timelines to life and intelligence exist around older stars, some civilizations could be hundreds of millions of years more technologically advanced than humanity, enough time to colonize the entire galaxy many times over, even at sublight speeds. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered the Drake equation, formulated by astronomer Frank Drake in 1961, estimates the number of communicating extraterrestrial civilizations in the Milky Way by multiplying factors including the star formation rate, the fraction of stars with planets, the fraction with habitable planets, the emergence rate of life in intelligence and technology, and the average communicating lifetime. Values for most terms remain deeply uncertain. Estimates of the final answer range from less than 1 to millions. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine. NASA Kepler Space Telescope, launched in 2009, found that approximately 22% of Sun-like stars have Earth-sized planets in their habitable zones. The TRAPPIST-1 system, 40 light-years from Earth, contains 3 potentially habitable rocky planets. Based on Kepler data, astronomers estimate there may be tens of billions of potentially habitable planets in the Milky Way alone, providing enormous statistical opportunity for life to arise independently of any particular civilization's history. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation. But the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, SETI, the search for extraterrestrial intelligence, has been conducted systematically since Frank Drake's Project Ozma in 1960. In over 60 years of searching, no confirmed artificial extraterrestrial signal has been detected. Breakthrough Listen, funded by Yuri Milner with $100 million, searched 1 million stars across a broad frequency range between 2016 and 2020, the largest and most sensitive SETI program ever conducted, and detected no technosignatures. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of the Great Filter, proposed by economist Robin Hanson in 1998, posits that some step in the development from non-life to spacefaring civilization is so difficult that virtually no species passes through it. If the filter lies behind us, if complex life, intelligence, or technology is extraordinarily rare, we may be essentially alone in the galaxy. If the filter lies ahead, if civilizations at our stage tend to destroy themselves, the implications for our own future are profoundly disturbing. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding. Infrared sky surveys searching for Dyson spheres, megastructures that would capture a star's entire energy output and be visible as an anomalous infrared source, have examined millions of galaxies without finding a credible candidate. Tabby's star, KIC 8,462,852, which showed unusual dimming patterns initially attributed to alien megastructures, was subsequently explained by dust. The absence of observable civilization-scale engineering across the observable universe is known as the Great Silence and remains unexplained. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations, and in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain the Fermi paradox. If intelligent life is common, where is everybody? This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that the great filter lies ahead of us. Technological civilizations reliably destroy themselves through nuclear war, artificial intelligence, biological weapons, environmental collapse, or some other failure mode. That becomes accessible at roughly our level of technology. The universe is full of dead civilizations that reached our stage and did not survive it. This is the most disturbing resolution of the paradox and is considered by some astronomers to be the most probable given the depth of the silence. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that the zoo hypothesis, John Ball, 1973, proposes that advanced civilizations observe Earth but deliberately refrain from contact, either under a galactic non-interference protocol or because contact with primitive civilizations is considered dangerous or pointless. The dark forest theory from Liu Cixin's The Three-Body Problem proposes that civilizations hide because the universe is a predatory environment where revealing one's location invites destruction. Both hypotheses are unfalsifiable by definition. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that the rare Earth hypothesis, Ward and Brownlee, 2000, argues that Earth's conditions, its position in the galaxy, the presence of Jupiter as a shield against asteroid bombardment, the Moon's stabilizing effect on axial tilt, plate tectonic, CS liquid water, are so extraordinarily unusual that complex life is effectively unique or nearly so in the Milky Way. On this view, the silence is expected. We are alone or nearly alone because the conditions for complexity are vanishingly rare. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding the Fermi paradox, if intelligent life is common, where is everybody, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes Kepler data establishing that roughly 22% of Sun-like stars have Earth-sized habitable zone planets, means the Milky Way contains billions of potentially habitable worlds. JWST is now capable of analyzing the atmospheric composition of nearby exoplanets and searching for biosignatures, oxygen, methane, water in combinations that indicate biology. No biosignature has yet been confirmed. The first confirmed detection would transform the Fermi paradox debate by establishing that life arises independently, making the silence of intelligence even more puzzling. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented Breakthrough Listen's search of 1 million stars across the 1 to 10 GHz frequency range found no technosignatures. Infrared surveys examining millions of galaxies for anomalous heat signatures consistent with Dyson spheres found no credible candidates. The statistical weight of these null results is significant. We have now searched extensively enough that the absence of obvious signals from nearby star systems is a meaningful data point, not merely a gap in our observational coverage. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed the WOW signal 1977 remains the only detected radio event matching predicted extraterrestrial transmission profiles, but it has never recurred and cannot be confirmed. Tabby's star excited SETI researchers in 2015, but was explained by dust in 2018. Every candidate anomaly investigated to date has received a mundane explanation or remained unconfirmed. The pattern of null results across diverse detection strategies and frequency ranges makes the silence increasingly difficult to attribute to insufficient searching. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding the Fermi paradox. If intelligent life is common, where is everybody? Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. NASA commissioned its first formal SETI study in 30 years in 2021, marking a shift in institutional attitude toward the search. JWST is actively searching exoplanet atmospheres for biosignatures. A detection would transform the debate. Breakthrough Listen continues operating. The Fermi paradox grows more acute as our instruments improve and the silence persists. The discovery of thousands of exoplanets has made the Drake equation's optimistic terms harder to dismiss, which makes the absence of any signal more, not less, disturbing. Whether the filter is behind us or ahead of us, the answer to Fermi's question will be the most consequential discovery in the history of science. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of the Fermi paradox. If intelligent life is common, where is everybody? From the historical record, through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Fermi paradox ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.